Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to see about a new distribution which is called as uniform distribution. Now in order to understand about this uniform distribution, there are two types of uniform distribution that you should really know. One is continuous uniform distribution, and as you see over here it is written as continuous. So obviously this distribution is created for a continuous random variable and we specifically use a probability density function. Similarly, the second type is something called as discrete uniform distribution. And since the name is discrete, over here you have discrete random variable. So we specifically use a probability mass function. Now in this video, we will go in depth. We will try to understand about continuous uniform distribution. We'll see multiple examples. We'll see about the notation and what all notations are specifically used. We'll understand about this specific diagram of this particular distribution. After that, we'll also go ahead and cover about discrete uniform distribution. We are also going to see multiple examples considering this kind of distribution. So first of all, let's go ahead and talk about continuous uniform distribution. And over here, first of all, we'll go ahead with the definition. As I have already told you, continuous uniform distribution basically means it is a distribution for a continuous random variable, right? So I'm just going to go ahead and write continuous random variable. Okay, so in probability theory and statistics, the continuous uniform distribution or rectangular distribution, it is also called as a rectangular distribution, are a family of symmetrical probability distribution. Such a distribution describes an experiment where there is an arbitrary outcomes that lies between certain bounds. Okay, certain bounds. So here you will be able to see two bounds, A comma B. So your entire distribution will be lying between these two. Okay. The bounds are defined by the parameters A and B, which are the minimum and the maximum value. Okay. So if I just talk about the notation over here, how do we denote this uniform distribution? It is basically denoted by A comma B. Here, what does A actually mean? It is the minimum and the maximum value. So I can consider this A and B as my parameters. Okay. So this A and B ranges between minus infinity to less than A to less than B to less than infinity, right? Always remember B will be greater than A and this will be ranging between minus infinity to plus infinity. Now let's talk about the PDF function that is specifically used in order to create this particular distribution. Okay. So here there will be two scenarios. One scenario will be that if my X value, which is my random variable, it is either A comma B. Okay, if it is A comma B or between A comma B, then my PDF will specifically be used as 1 minus B minus A, 1 by B minus A. I will explain you about this by showing you example, but just right now, just consider that if my X value belongs to A comma B, then my PDF is basically created by 1 divided by B minus A. Okay, otherwise it will be 0. Okay, 0 otherwise. So here you can see if it is less than A, then it is 0. If it is greater than B, it is 0, right? And when it is between A and B, it is nothing but 1 divided by B minus A. Okay. Similarly, if I go ahead and construct the CDF, which is my below diagram. Now with respect to this specific CDF, here also you have three different scenarios. One is if the value of X is less than A, if the value of X is less than A, then here you will be able to see that I'll be getting 0, right? And if the value is greater than B, you'll be seeing the value is greater than B, then again it will be, it will be 1, right? Over here it is 1. In short, cumulative basically means we need to sum up all the values with respect to the probability distribution, right? So these are my two scenarios for CDF, but what about in between, right? So if X belongs to A comma B, right? If X belongs to A comma B, then we specifically use something like X minus A divided by X minus A. See, X minus A, what does X minus basically A indicate, right? When you try to subtract X minus A, this is my entire X, right? Minus A. So you are basically talking about this region, right? So here X minus A divided by, if I do B minus A, B, this is my entire B, right? So what is B? And from this B, we are basically subtracting A. Right? So we really want to get this specific region whenever X belongs to A comma B. So that is the reason we use this specific formula. X minus A divided by b minus a. X minus a will basically give me this region, and b minus a will be giving me this specific region over here, right? So with respect to this, I'm actually trying to do the division, and I'm able to find out the CDF, right? And this is how my cumulative distribution function looks like. Along with this, you'll also be able to see the mean that is specifically used in order to calculate this distribution. It is nothing but 1 by 2 multiplied by a plus b. The median is also given by 1 by 2 multiplied by a plus b. And finally, the variance is given by 1 by 12 b minus a whole square. Now remember, I'm not deriving all these things, but it is good that we know these values. Again, derivation is not that important as suggested. We just need to understand about this specific distribution, and probably we'll get an idea like how this distribution looks like. But at the end of the day, I really want to specify multiple examples. So first of all, let's take an example and let's see what is a continuous uniform distribution. Let's say I have a problem statement. The number of candies sold daily at a shop is uniformly distributed with a maximum of 40 candies and a minimum of 10 candies. Okay, so my question will be that what kind of question as a data analyst you can basically ask is that what is the probability of daily sales to fall between 15 and 30. Okay, so this is my question, and this is how the entire question looks like. So what is the probability of daily sales to fall between 15 and 30? Let's understand the question. The number of candies sold daily at a shop is uniformly distributed with a maximum of 40 candies and a minimum of 10 candies. Okay, so what is the probability of daily sales to fall between 15 and 30? Let's take this as an example. So in order to solve this, first of all, we will go ahead and construct this particular graph, okay, the distribution, by using PDF. So this will be my number of candies sold, right, which will be my X value, right? Here, you know, your minimum value is 10 and your maximum value is 40, right? So this is fine, right? And your number of candies is between this value to this value. Okay. Now the reason why I'm drawing till here, because over here, your probability distribution will be what? According to the PDF, right? According to a PDF, if my values ranges between 10 to 40, then it should be 1 divided by b minus a. So 1 divided by b minus a is nothing but 1 divided by 40 minus 10 is nothing but 30, right? So here you are able to see this. Now my question is that what is the probability of daily sales to fall between 15 to 30? 15 to 30. Let's say this is 15, this is 30. I need to find out what is the probability of daily sales to fall between these values. Okay. So now I can go ahead and calculate it. I will go ahead and write probability of 15 less than or equal to random variable X less than or equal to 30. This is what we really need to calculate, right? Now, in order to calculate this, it is very simple, and the kind of formulas that we will be specifically using if I want to probably calculate this probability, right? Now, in order to calculate this, first of all, we will go ahead and define two variables. One is x1. X1 is nothing but 15. X2 is nothing but 30, right? Now, first of all, in order to do the calculation, we will do a difference of x2 minus x1. Then we will multiply by whatever probability that we specifically get over here, right? 1 divided by b minus a. So if we go ahead and just write it, so it is nothing but 30 minus 15 multiplied by 1 by 30. Okay. So here you will be able to see it is 0.5. So the probability of sales, of daily sales between 15 to 30 is somewhere around 0.5. And this is how we specifically do the calculation over here. My another question may be, what is the probability of my daily sales to be greater than or equal to 20 candies? Now, in this particular case, what we really need to do, if I'm considering this as my 20, okay, I need to find out this region, right? What is my probability of the daily sales greater than this, right? And less than 40. So in this particular scenario, what will be my x1, x2? My x2 will be 40 minus 20 multiplied by 1 by 30. So this would be nothing but 66%, okay, which is nothing but 0.66. So I'm writing it as 66%. So here I will be getting as 0.66, which is nothing but 66%. Okay. So I hope now you are able to understand with respect to any continuous uniform distribution, how you will be able to calculate these things. Okay. Now let's go to the next distribution, which is called as discrete uniform distribution. Now, whenever we talk about discrete uniform distribution, since we are talking about number one, that is discrete random variable. So here we are basically talking about discrete random variable. Okay. The second thing over here is that we basically use a PMF to showcase this entire distribution. So let's take an example for this. So example over here will be like rolling a dice. Now in the case of rolling a dice, the outcome is 1, 2, 3, 4, 5, 6. And you also know that probability of 1 will be 1 by 6. Probability of 2 will be 1 by 6. Probability of 3 will be 1 by 6. Like that, probability of any number will be same. Why? Because we consider this as a fair dice. So just by seeing this probability mass function, you will be able to see that my value will be ranging between a comma b, right? A comma b basically means 1 comma 6, right? So 1 comma 6. And in order to find out the probability, it is nothing but 1 by n. N is the number of outcomes, right? So if you probably go ahead and see how this n is getting calculated, right? We are basically using this 1 by n, right? That is the probability for every outcomes, right? So 1 by n, in this n will be calculated by using this formula, b minus a plus 1. What is b in this case? B is the number, like this can be b, this can be a, right? A, b, right? Because your outcomes is ranging between 1 to 6. So here I will go ahead and write 6 minus 1 plus 1, which is nothing but 6, right? And finally, you'll be able to see for every probability will become 1 by 6, right? So what is the notation that is specifically used over here? So notation will be nothing but uniform a comma b. In this, you will be having the parameters. So parameters will be nothing but a comma b. Here, your b will be greater than or equal to a. Okay, that needs to be there. Because obviously the maximum outcome, the best outcome that you'll be seeing is with respect, not best outcome. Over here, you'll be able to see that this b is always greater than or equal to a. Okay. PMF is basically calculated by 1 by n. Okay. You really need to remember this. So if the x value is less than, it cannot be less than a, because at all the time for every outcomes, you'll be able to see that my probability will be almost same. And if I talk about mean and median, it is same like our uniform distribution, continuous distribution, that is nothing but a plus b by 2. Okay. So this is one example, and the reason we are basically getting the cumulative distribution is that we are adding up each and every probability. So when we keep on adding it, you'll be able to see that finally I'll be able to get 1. But always understand your so with respect to the definition, if I see in probability theory and statistics, the discrete uniform distribution is a symmetrical probability distribution wherein a finite number of values are equally likely to be observed. Every one of n values has an equal probability 1 by n. Another way of saying is that it would be known a finite number of outcomes equally likely to happen. Okay. So for every distribution, for every outcomes, you'll be having the same probability 1 by n. And this is how the entire diagram looks like. Okay. So in this example, I have shown you with respect to rolling a dice, or if we also want to probably consider Bernoulli distribution, like tossing a coin. I know the outcome is 2, right? But at all the time, you'll be getting 1 by 2 as a probability. Probability of head is 1 by 2, probability of tails is 1 by 2, considering that it is a fair coin. So I hope you are able to understand about this two important distribution, which is called as uniform distribution. This was it from my side. I hope you like this particular video. I will see you all in the next video. Thank you.